Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ibn Shafiq, and today me and my team are gonna present on our GBI project, which is Penang Private School. Okay, Penang Private School aim is to provide a high quality education while emphasizing sustainability in infrastructure and curriculum. Our school will be constructed on the vacant ground located at Rumkalan Tambang Penang, with emphasis of 14.23 acres with a greenery and other natural features that can foster environmental stewardship and sustainability. Our school will have an environmental friendly structure such as renewable renewable energy resources, water conservation system, and also green area for experiential learning. At the same time, it will it will lessen overall impact on the environmental while simultaneously raising student knowledge on the importance of the nature. There are several factors that we need to be aware before choosing our site, such as soil condition, accessibility, and also its susceptibility to natural disaster. And after taking into consideration, our site is appropriate to construct a school development plan because of its considering its accessibility, infrastructure, and low susceptibility to natural disaster. Although not immune to natural disaster, Penang is not a region that have a severe flooding incident. That's all. I will pass to our next member.
Hi, my name is Konori Frank Frederick, and today I'm going to explain about the GBI tools that we have selected, which is non-residential new constructions. And I'm going to explain it. How does it make more greener and sustainable? First, it has a net zero energy design. The school achieved net zero energy use through solar panels, geothermal heating, and energy efficient systems. A 2023 report by the World Green Building Council states that net zero schools can cut their carbon footprint by 90% compared to conventional buildings. The next one is water conservation. Rainwater harvesting systems collect and reuse rainwater for irrigation and non-potable water, cutting consumption by up to 50%, as shown in 2018 study by the California Water Efficiency Partnerships. Next is water reduction and recycling. On-site composting and recycling facilities minimize waste generation and promote resource recovery. This was also from the report studied by the Environmental Protection Agency that found schools with comprehensive recycling programs can reduce waste sent to landfills by 70%. Next one is durable and low maintenance materials. The school uses durable, low maintenance materials such as recycled concrete and FSC certified wood, minimizing the need for frequent repairs. And the last one is natural ventilation and lighting. Ample windows and skylight enhance natural light and ventilations, reducing reliance on artificial lighting and cooling systems, thereby lowering energy consumption. This was also a study from Lawrence Berkeley National Laboratory revealed that schools with optimized daylighting can slash lighting energy consumption by up to 75%. Okay, the next one, I'm going to highlight the nature of conflicts among various factors in this project. Green technologies like solar panels and natural ventilation systems are appealing for the environmental advantages. However, their initial costs are high, demanding innovative financing and detailed life cycles analyzed for long-term savings. Integrating these technologies seamlessly is a significant challenge, requiring expertise to create a cohesive and functional whole. Next one is societal and cultural challenges. Beyond infrastructure, societal and cultural factors create a complicated situations. Worries about how things looks and potential issues in how well the community functions need a careful attention. It is important to handle these concerns with care and openness to gain approval and backing from the public. Additionally, inclusivity is crucial. A green school, despite its environmental benefits, needs to be open, including those with physical limitations. It is crucial to create a truly sustainable and equitable learning environment. Dealing with loss and safety adds more complexity. There are specific rules and certifications for green buildings that keep changing and vary by locations. Complying these rules is crucial for schools. Focus on sustainability and expertise in this area is needed to avoid bureaucratic issues. Safety is a top priority too. Green features shouldn't get in the way of emergency procedures or fire safety. This means careful planning and thorough testing needs to be done to make sure everyone in the school is safe. And lastly, health and well-being considerations bring up important questions. Parents might be concerned about potential health issues with rainwater reuse systems and natural ventilations, especially for students with allergies and sensitivities.
Hello, my name is Aizlin Rahman. So I will present to you about Task 3, Green Building Index tools. So for this Task 3, we are referring to the GBI assessment criteria for non-residential new construction and RNC. So for energy efficiency, EE1, for minimum EE performance, we are using material like wall and roof insulation, and we are upgrading the incandescent light to the LED lighting. So for this insulation, it can prevent from heat gain, and then for LED lighting, it can save energy about 75% than the incandescent lighting. So for EE2 lighting zone, we are using occupancy sensor and daylight sensor or a photocell. So these two can create energy efficiency awareness, which is it can reduce energy consumption. So for EE4, the renewable energy, we are using solar panel. So as we know, Malaysia is receive abundant sunlight every year. So solar is suitable for to use in our school, and then it can give sustainable energy, give cost saving, and then the minimal greenhouse gas emission. Okay, and then for EE5, we are using EE5 advanced EE performance. We are using autoclave lightweight concrete, which it can give lightweight, create lightweight and durable building material, and it can give low density and high fire resistant. And then for our EE, the total point score is 24 over 35. Okay, next is indoor environmental quality. Okay, we start from EQ2, which is environmental tobacco smoke. The material we use is smoke detector, so it can integrate with fire safety plan. And then for EQ4, indoor air pollutant, we are using low VOC pen and coating. So for this material, it can give health and safety, which can emit fewer chemical, and then from this we can improve the indoor air quality. Okay. And then next, we go for mold prevention, EQ5. Material we use is damp-proof membrane. So damp-proof membrane can keep indoor humidity below 70% RH, and then it also durable and effective in moisture control. So, and then for EQ8, for the daylighting, we are using light shelvers, which is it can resulting in energy saving, especially for a lamp. And then and lastly, for external view, okay, so our school is give reduce eye strain for the student, and then for the teacher, for building that we can provide long distance view and connection to the outdoor. So for EQ, the total of our point score is 8 over 21. And then lastly, and then for sustainable site planning and management, for the site selection, our school is located at Pengkalan Tambang, which is it away from national plan for reserve forest. And then so for SM3, for development density and community connectivity, we construct on a previously developed site and in a community with a minimum density of 20,300 meter per hectare net. For our school environmental management, we conserve existing natural area, and we should restore and protect a minimum of 50% of the site area. Okay, lastly for SM12, greenery and roof. Okay, our school using green roof, which Malaysia has high tropical climate and high temperature. This green roof can help regulate building temperature, and it can manage stormwater runoff, and it's suitable for school in Malaysia. Okay, for this SM, our total score is 5 over 8. And then I'm giving to our member, Honorary Frank. Thank you.
For the next criteria that we have selected in our projects is in materials and resources, we have 6 criteria, and the total point scored is 7. And for water efficiencies, we have 5, and the total point scored are 8. And the last one for innovations, we have a total score of 7. And from the total GBI score overall is 59, makes us our projects in as a certified green building.
Hi, Assalamualaikum. My name is Siti Nuraisha, and I will explain about problem and solution and ethical consideration taken by clients, architects, M&E, QS, and civil engineering. For clients, there are many major that clients faces the challenges, which is budget constraint, inadequate knowledge about GBI, which is the clients not fully understand and unfamiliar with GBI, and then different expectation of GBI. For the architects, they're balancing aesthetic and sustainability, which are their challenges and cost implication. However, for the civil engineering, which is design and construction challenges, and material selection, which is ensuring that the extraction or harvesting of raw material is done sustainably without causing ecological harm or depleting finite resources. For the M&E, which is mechanical and electrical engineer, there are some challenges, which is technological issues, safety concerns, which is mechanical and electrical system must comply with safety standards. However, for the quantity surveyor, the challenges that they encounter, which is limited availability and cost of green material and limited data. So for the solution that overcome their challenges, which is firstly high potential contractor, education and awareness by conducting workshops to enhance clients to understand of GBI principles, and then TU communication, diversify material sourcing, integrated design strategy, utilize effective communication strategies, and integrated project delivery, which is FAD methods. Also, work with suppliers and manufacturers are important. Working with suppliers, adhering to sustainable and ethical practices. And then through our planning, detailed project assessment to identify and address technical challenges proactively. Also technical skills, conduct research and benchmarking, invest in training, and monitor market trends. So for ethical consideration, which is environmental ethics, social ethics, and health and safety. For the positive impact of environmental ethics, by minimizing environmental effect, lowering resource use, and encouraging the use of renewable energy sources, this corresponds with ethical principle. However, certain high-tech materials manufacture and disposal may have negative effect on the environment. For the social ethics, the positive impact, new technology can improve construction productivity and perhaps reduce costs. But the concern is the introduction of advanced technologies in construction has the potential to disrupt traditional job markets, potentially leading to job displacement. And then for the health and safety, the positive impact, the automation of hazardous operation and the incorporation of technology-driven safety measures have the potential to drastically minimize the dangers usually connected with construction work. For example, using the drone at a site to see the workers' progress and then the project progress. However, workers who are not adequately trained to operate, supervise, or interact with modern equipment may face greater hazard and jeopardize overall safety. That's all for me. Thank you.
Hi, my name is Menikresha binti Effendi, and I will be presenting about the return on investment. So, first of all, after we have analyzed our project, the total initial cost is 1,096,700, and meanwhile for the maintenance cost, it is about 147,850 ringgit. And for the operational cost, the value is 314,000 ringgit. So for the return on investment, after we have made the calculation, the Penang private school is negative 74%. The project experiences losses from what is being earned because the value is negative, so the net loss is implied when the cost of the investment exceeds the net income. And also, the year required for the return on investment is 7 years. In conclusion, we obtained important insights pertaining to the learning objective of this course by analyzing the project objective, the design components, and also the possible results of our project. So after all the planning and all the analyzing, we have got a certified for GBI rating for our project, which is Penang Private School. So the innovative sustainable design of this Penang Private School is hopefully can help to protect our ecosystem and lessen our carbon footprint. And by designing this school building, this project aims to promote environmental responsibility among students, among the faculty and surrounding community. That is all from us. Thank you.